So what I have on the itinerary for us today is literally just this in-class assignment and then a lab assignment. We have already covered all of the lecture material required for our transient analysis of RL and RC circuits. So this is just a single in-class assignment problem that involves having multiple energy storage elements because there are two inductors. And so I'm just going to give you guys a little hint and then let you go about your business while I try to either A, find out where my little baggie full of capacitors for the lab went, or B, calculate new frequencies for you to use with some of the capacitors that I have in there because somebody walked away with some of my equipment. So that'll just take me a couple of minutes. So with regards to this in-class assignment problem, you are asked specifically to determine the voltage drop over the current source as a function of time. Okay? And you can use the methods that we've introduced in class over the past couple lectures to do this. The only thing to point out here is that while you are not specifically asked anything having to do with the inductor current, you are going to need to figure out what that is to understand how to analyze the circuit at t is equal to 0 plus, because you all know, I hope, by this point that the inductor current cannot change between t is equal to 0 minus and t is equal to 0 plus. Because there are two inductors, we can either have to figure out what both of those inductor currents are, which is difficult, or combine those two inductors into a single inductor and then find out what that single equivalent current would be that's flowing through both inductors, which actually makes this problem much easier. So a question that I get asked an awful lot is, where do I know how to put, or where do I put the equivalent inductor in? And so to answer that, what I'm going to do is show you something that I believe makes a lot of sense and really just goes along with everything that we've done previously in this class. And so what I'm doing here simply is I'm identifying the nodes that the inductor network is connected to. So I have that red node up there, and then I'm going to have this green node down here. Both inductors are connected between the red node and the green node. So the equivalent inductance would involve taking those two inductors out and replacing them with a single inductance connected between the red node and the green node. So what is 1 Henry in parallel with 3 Henrys going to look like? 3/4 of a Henry, absolutely right. So what I'm going to do here is I'm going to erase these inductors. Like so, and then put in between the red and the green node, and where I don't know why the 3 Henry somehow managed to survive me scribbling it out. Let's try this again. And so anyway, anywhere between the red and the green nodes is perfectly acceptable. So I arbitrarily choose to put it right here. So here is my 3/4 of a Henry inductor. And just for the sake of argument, I'm going to choose my inductor current IL of T in this direction, and then you should be off to the races. You can treat it like any other circuit that we've dealt with previously. All right, so take a couple of minutes to work on that while I get the lab set up.